Bismillahirrahmanirrahim. Assalamu alaikum. Today I will solve Cambridge ASNA level mathematics paper 4 mechanics October number 2222. Now let's start the paper. Question 1. A cyclist is riding a bicycle along a straight horizontal road AB of length 50 meters. The cyclist starts from rest at A and reaches a speed of 6 meters per second. At B, the cyclist produces a constant driving force of magnitude 100 Newton. There is a resistance force and the work done against the resistance force from A to B is 3,560 joules. Find the total mass of the cyclist and the bicycle. You see here, this is the road AB on which the cyclist is moving. Now you see here the cyclist start from west, therefore the speed of the cyclist, starting speed is 0 and reach the speed 6 meter per second. Now the final speed is 6 meter per second, and here is the distance between A to B is 50 meter, and this is the distance between 50 meter from A to B. Now the cyclist produces a constant driving force. The driving force Ft is 100 Newton, and there is a resistance force and the work done against resistance A to B is 3,560 and the work against resistance is 3,560 joules. And to find the mass of the cyclist, we use here the work energy principle. Now the work done by net force is equal to change in mechanical energy. Now you see here the work done by net force, that's equal to work done by driving force minus work done by resistive force, that's equal to change in energy. Total energy change here is, you see, the speed is 0 at A and the speed increases at B to B is 6. Now therefore the total change in kinetic energy will be equal to 1 over 2 of mv delta V square. Now you see here the work done by driving force, that is equal to F into D. Now you see here the driving force is 100 Newton multiply the distance, total distance you see here A to B is 50 meter minus work done against resistance, that is the work done against resistance 3,560 joules equal to half. Now we have to calculate mass and the speed, starting speed is 0 to 6. Now we write it as v square minus u square. Therefore, that will be equal to 5,000 minus 3,560. That's equal to 1 over 2 m into v square is 6 square minus 0. Now we calculate it. That value will be equal to 1440 equal to 1 over 2 multiply 36 into it. Now that value is 18 and the term will be equal to 1450 divided by 18. Now you see here the 1440 divided by 18, the answer is 80. Therefore, 80 kg is the answer. Question 2. A particle P of mass 0.4 kg is in limiting equilibrium on a plane inclined at 30 degree to the horizontal so that the coefficient of friction between particle and the plane is 1 over 3 square root 3. Now, firstly, we draw the plane here. This is the plane, and that's making angle 30 degree with the effect. Now, this is 30 degree with the horizontal. Now, this is the particle P, and the forces acting on this particle is the one weight of the particle, that is equal to 0.4. Now, next force is the normal contact force, that is R. This is the normal contact force. R. And other is friction between the plane. This is the friction. The body is moving downward, therefore the friction will be along the surface in upward direction. That is the frictional force. Now the forces are resolved along the surface and perpendicular to the surface. That is, this is the perpendicular to the surface, and that force is along to the surface. Now you see, this is the adjacent component. Now the component along the surface will be W sine 30. Particle is in equilibrium, therefore the forces acting on this particle along the surface, that is F, and the next force is W sine 30. The sum of these forces will be equal to 0 because the particle is in equilibrium. Therefore, we can write it as F is the frictional force. We can write it F equal to mu R minus W sine 30, that is equal to mg sine 30 degree. And here is R. You see here that is R will be equal to W cos 30. W cos 30 degree, and that is equal to mg cos 30, mg cos 30 degree. Now we write it as mg cos 30 minus mg sin 30 equal to 0. Now you see here m is equal to 0.4 g into cos 30 minus 0.4 g into sin 30, that is equal to 0, and we can write it as mu equal to 0 mu into 0.4 g cos 30 equal to 0.4 g sin 30. That value will become mu will be equal to 0.4 g sin 30 over 0.4 g cos. Now we can write it as 0.4 and 0.4 will be cancelled, b will be cancelled. Now the tan 30 will be equal to sine over cos is tan theta. Now we can write it tan 30 and we calculate it. Now you see here the tan 30 equal to square root 3 over 3. Now we can write it as square root 3 over 3 the answer. The force of magnitude 7.2 Newton is now applied to P directly up a line of greater slope to the of the plane. Part B, given that P start from rest and find the time it takes to for P to move 1 meter up the plane. Now you see here the forces acting on this particle is W sine 30 along the surface in downward direction, and the force normal to the surface is R, and the downward force is the weight of the body, and other is the component of this force perpendicularly the surface is W cos 30. Now you see here these A force of magnitude 7.2 Newton is applied to P up of the plane, up a line of greatest slope of plane. You see here, this is the force 7.2 Newton that is acting in, that is applied force. Now you can see that as applied force is 7.2 Newton. Now when the body is moving up the plane, therefore the friction between the plane and the particle will be in the downward direction. Now this is the frictional force mu r. Okay. Now we see that the forces acting on it, this particle. One is the applied force, that is Fa, minus the frictional force mu r, minus the force is the weight of the body, that is equal to mg sine 30, and this is the net force acting on this particle, and that will be equal to m into a. From this equation we can find the acceleration of this particle when the net force is Fa minus mu r minus mg into sine theta. Now the applied force you see here, that is the 7.2 Newton minus mu, we already find the square root 3 over 3, and r is the W cos 30 degree. You see here, r is equal to the upward force equal to the downward force, that is W cos 30. Now we write it W cos 30 minus mg cos 30 degree minus mg sine 30 degree is equal to m is 0.4, a is written as it is. Now we calculated 7.2 minus square root of 3 over 3, m is 0.4 and g is written as 10 and cos 30. Now the value of the cos 30 is under root 3 over 2 minus m is 0.4 and g is 10. Sine 30 is 1 over 2, that's equal to 0.4a. Now we simplify it. As 0.752 is written as it is, minus 0.4 is divided by 2 is 0.2. Now multiply square root 3, multiply square root 3, we get 3 over 3. Multiply 0.2 multiply 10 is 2. Minus 0.4 multiply 5 is 2. That is equal to 0.48. And the answer is 7.2 minus 4 will be equal to 3.2, and this is equal to 0.48. Then a will be equal to 3.2 divided by 0.4. We calculated the answer will be equal to 8 meter per second square. Now we have to find the time that it takes for P to move 1 meter up. You see here that start motion from west, therefore U is 0, A is 8 meter per second square, and the distance it covers in upward up the plane is 1 meter. Therefore, to find the time we use the uniform acceleration motion equation, that is equal to s equal to ut plus half at square. And now substitute the value. U is 0 into t plus 1 over 2. A is 8, t square is written as it is, and s is 1. Now that is equal to 4t square equal to 1. Then t square will be equal to 1 over 4, and that is t will be equal to 1 over 2 plus minus 1 over 2. Now we start only t equal to 1 over 2. This is the answer. Question 3. A particle of mass 0.3 kg is held at rest by two light inextensible springs. One spring is attached to the at an angle of 60 degree and to the horizontal. The other spring is attached at an angle alpha degree to vertical wall. The tension in spring is attached to the ceiling is 4 Newton. Now you see here this is the tension in this spring is 4 Newton, and find the tension in this spring which is attached to the wall. This is the spring attached to the wall, and this tension we name it as force P2, and this is named as P1. Now to find the tension in this spring, firstly we see that which forces are acting on this particle. One is the P1 tension of the spring which is attached to the ceiling, and that is the next is P2, and we see here this is the force, but in downward direction is the weight of the particle. You see here the weight of the particle will be 0.3 g. Now we can write it W equal to mg, and that is equal to 0.3 into 10, and that is equal to 3 Newton. Okay, the forces acting on these particles, there are three forces. One is the weight of the body, other is the tension of the spring. Now this is the tension T1, this tension is T2, and this is W. Now we name it as the angle between P2 and W is alpha, angle between the P1 and W is beta, and we name it as gamma. You see here the angle between the spring and the wall is alpha, and these two lines are parallel. Therefore, the angle between T2 and W weight will be also alpha because this is the alternate angle. Now we name it as alpha here. And the second force, second angle we have to find the T1 between the W. This is the line which is perpendicular to the ceiling, and this is the 90 degree. Now this angle will be equal to 30 degree because the interior sum of interior angle of triangle is 180, therefore this is 30 degree. Now the angle between T1 and W, that angle we name it as beta. Beta will be equal to 180 minus 30 degree. You see here, so this angle is 30. This angle is 30 degree. Therefore, the remaining angle is equal to 180 minus 30. That is equal to 150 degree angle. Okay. Now the gamma angle, for we can find this gamma angle. You see here, this angle is alpha, and that is equal to interior and sum of interior angles of parallel line is 180. You see here, this is lines are parallel. Therefore, this line is parallel to each other, and then angle equal to 180 minus alpha. Now the total angle will be equal to this angle between T1 and T2. This is the total angle between T1 and T2. Now this angle is 180 minus alpha, and that is 30. Now we can write it as gamma will be equal to 180 minus alpha plus 30 degree, that is equal to 210 minus alpha. Now the alpha is written as alpha. Therefore, we use the Lem's theorem. T1 sine alpha equal to T2 sine beta equal to W over sine gamma. Now you see here the T1 is 4. We write it as T1 over sine alpha. Alpha is alpha. T2 is, we have to find T2. This is the T2, and we have to find that value is T2 our sine beta. Beta is 150 degree, and W is the weight of the body. You see here, this is the 3 Newton, 3 our sine 210 minus and minus alpha. Okay. Now we take the fraction t to t 4 over sine alpha, 4 over sine alpha equal to 3 over sine 210 minus alpha, and we simplify it. Now we cross multiply 4 sine 210 minus alpha will be equal to 3 sine alpha. Okay, now that's 4 sine alpha 210 minus alpha. We use the formula sine alpha minus beta, that's equal to sine alpha cos beta minus cos alpha sine beta. Now we substitute formula sine 210 cos alpha minus cos 210 sine alpha, that's equal to 3 sine alpha. Now sine 210, that is equal to sine 210 is minus 1 over 2, and cos 210 we see that cos 210 minus under root 3 over 2. Now we write it minus 1 over 2, and the cos alpha is written as it is, and minus sine alpha is written as it is, and 3 sine alpha. 4 times minus 1 over 2 is minus 2 cos alpha, and that is equal to minus minus plus 2 square root of 3 sine alpha equal to 3 sine alpha. Now we can write it as minus 2 cos alpha is equal to 2 sine alpha minus 2 square root of 3 sine alpha. Now the sine alpha is taken as a common, that's equal to 3 minus 2 square root of 3 into minus 2 cos alpha. Now we can write it as sine alpha our cos alpha, that is equal to minus 2 over 3 minus 2 square root 3, and that's equal to tan alpha will be equal to, and minus 2 is a common, now the 2 over 2 under root 3 minus 3, therefore alpha will be equal to tan inverse 2 over 2 square root 3 minus 3. Now you see here tan inverse 2 over 2 under root 3 minus 3, that's equal to 76.93. This is the answer. Alpha is equal to 76.9 degree is the answer. Now we have to find the tension in the spring. You see here the tension in the spring. Therefore, we already find the alpha. Now we can find tension easily. Now you see here, this is the 4 over sine alpha. Now we write it here 4 over sine alpha will be equal to T2 over sine 150. Now 4 sine alpha sine 76.9 equal to T2 sine 150 degree, and now T2 will be equal to 4 multiply sine 150 degree over sine 76.9. We calculate it. Now you see here the tension will be equal to 4 multiply sine 150 divided by sine 76.9, that's equal to 2.05 is the answer. Now 2.05 Newton is the tension in the spring. This is the answer. Now question 4. A car of mass 1200 kg is traveling along a straight horizontal road AB. There is a constant resistance force of 500 Newton when the car passes a point. It has speed 15 meter per second and an acceleration of 0.8 meter per second square. Find the power of the car engine at A. Now you see here this is the road AB. Now this road AB. Now the car goes at this car and the weight mass of the car is 1200 kg, and this is the mass is 1200 kg, and the constant resistance force of 500 newton. The resistive force is 500 newton, that is resistive force. And when the car passes A, that is the point A, the speed is 15 meter per second square per second. That's the speed of that A. The acceleration is 0.8 meter per second square, and the power of the car engine at A. Now you see here the power of the car will be equal to F into V. Now we write it as P equal to F dot V. Now firstly we see here the speed of the car is 15 meter per second, F into 15, but we have to find the uh, force. Now you see here the driving force. This is the force acting on the car is F. Now the driving force minus resistive force, that is equal to net force, and this is will be equal to driving force is F minus R is 500 Newton, and the driving force and the net force equal to MA. Now here this M is 1200 and A is equal to 0.8 meter per second square, that is equal to 960, and F minus 500 equal to this, and the F will be equal to 960 multiplied by F plus 500, that is equal to 1460. Therefore the power will be equal to F into 15, and multiply force is 1460 multiplied by 15. Now we see the value 1460 multiply 15. The answer is 21,900 watt is the answer. The next part, the car continues to work with this power as it travels from A to B. The car takes 53 seconds to travel from A to B, and the speed of the car at B is 32 meters per second. Show that the distance is 1,362.6 meters. Now to find the distance AB, we applying the work energy principle. In the work energy principle, that's the work done by driving force minus the work done by resistance. That will be equal to the total change in mechanical energy. Now the total change in energy, that is the, now to find the work done by driving force, we use the formula here is equal to W over P. That will be W will be equal to PT. Now we can write it PT minus resistive work done by resistive force, that is you see here it's equal to force into distance. The force resistive force into distance, you see here the resistive force is 500 Newton into distance, and that is equal to the distance covered from A to B. This is the distance covered from A to B. Now the total change in kinetic energy, that's equal to half m delta V square. Now The power of the engine here is the 21,900 Newton watt. Into the time taken is 53 seconds. We can write it as 53 minus 500 multiply D. That's equal to 1 over 2. M is 1200 and V square will be equal to V square minus delta V square equal to V square minus U square. You see here the speed at this position. This is the initial speed and this is the final speed at V. That will be equal to 32 meter per second. And now we write it as that's equal to 600 into V square is 32 square minus 15 square and that is 500 D and 21,900 multiply 21,900 multiply 53 that will be equal to 11,6,700 11,6,700. Now to find the value that will be equal to 11,6,700 minus 600 into 32 square minus 15 square will be equal to 500 B. Now we calculate it. Now 11,6,700 minus 600 into 30 square. Now minus 15 square. That's equal to 68,1300 divided by 500. That's answer equal to 1362.6. The distance equal to 1362.6 is the answer. Hence, this is the proof that the distance from A to B will be equal to 1362.6. This is the answer. Question 5. A block A mass 80 kg is connected by a light extensible string. Block B mass 40 kg and the rope joining two blocks is taught parallel to line of greatest slope which is inclined angle 20 degree to horizontal, a force of 500 Newton inclining angle of 15 degree above the same line, greatest slope on A. The block moves up the plane and there is a resistance 15 Newton, but no resistance on A. Now we see here the forces acting on the block A. Say 1 is the force is the weight of the body. This is the weight of the body. And the one other is the tension of the spring. You see here, this is the tension of the spring, and that is the force acting on this is the 500 Newton, and the force along the surface will be 500 cos 15 degrees. The force along the surface. Now the other force is the normal contact force. This is the force acting in the direction, then we name it as R1 RA. Now there is no resistance force, therefore you see here there are no resistance force on it. Now we see the component forces of the weight. The one is the perpendicular to the surface of the force. That force will be that is the force W cos W cos 30 degree, 20 degree. That's the angle with the incline making with the x-axis. This angle will also be 20. Next is the force along the surface that is equal to W sine 20 degree. Now these are the forces acting on A. Now we write the equation. First you see here this is the 500 cos 30 15 degree minus W sine 20 degree minus tension, this is the tension of the spring, that is equal to MA. Now next we see the M is the, you see here the M is 80 kg, that's we can write it 80A. Now the forces acting on the block P, you see here one of the force is the tension of the spring, other is the normal contact force of the on the forces acting on the block P is the one is the weight of the block P, and another is the normal contact force of the on the block P. Now you see here WV that's equal to 40 into 10, that's we can write as 400 Newton. Now the other forces is the resistance. Now you see here 500 Newton, there is the 50 Newton force. This is the 50 Newton force on the resistive force. That's the 50 Newton. We know that resistive force is 50 Newton. Other forces on this block is the component of this W weight of the body. One is the along the surface of the one is the along the surface, that force will be equal to W sine at 20 degree. This is the angle which incline me to the x-axis. Now this other component will be, this is the second component perpendicular to the surface, and that will be equal to W cos 20 degree. The angle between this 20 and because the angle incline meeting with the x-axis is 20 degree. Now these forces we all mentioned here, one is the weight of the body, other is the resistance force, and second also another force is the tension of the spring. This is the tension of the spring, we write it as T. Okay. Now this equation becomes, you see here, one is the tension T, we write it as T minus 50 Newton minus WB sine 20 degree, that's equal to MA, M is the 80, and now these two equations, now we simplify it here. Now the values of 500 cos 15 degree minus W sine the W is mg, then M is 80 into G is 10, now 800 sine 20 minus T equal to 88, and same here is T minus 50 minus M is, you see here there is the M is 40, there is the M is 40A, now that is M is 40, 40 into 10, that's 400 sine 20. WB is equal to mg, and that is equal to 40 into 10. Now 40A is written as it is. Now see here what is the value of 500 sine cos 15 degree. You see here 500 cos 15 minus 800 sine 20, that's equal to 209.34, 209.34 minus P equal to 88 minus 400 into sine 20 degree, that's equal to minus 186.8, minus 186.8, that's equal to 48. Now you see here the tension will be equal to 209.34 minus 80, and here is the tension will be equal to 48, that's equal to 88, and T is equal to 40A minus plus 186.8. So again we put the value of T here is that will be equal to 40A plus 186.8 equal to 209.34 minus 88. Now that value will be equal to 128. 88 is from right to left side. Now 209.34 minus 186.8. That will be equal to 209.34 minus 186.8 divided by 120. Now 209.34 minus 186.8, the difference is 22.54 divided by 120. You see that the answer is 0.187. This is the acceleration 1876, and we can write it as 0.188. And now to find the tension, here we see that the tension equal to 40A plus 186.80 is this equation. Now we put the value 40 multiplied by 100, 0.188 plus 186.8, that will be equal to 0.188 multiplied 40 plus 186.8, that will be equal to 194.3. 154.3 Newton is the tension. In the part B, find the time it takes for the block to reach the speed 1.2 meter per second from rest. You see here, the speed of the block, initial speed is 0, the speed is 1.2 meter per second, and the time we have to find. The acceleration we already find of the block 0.188. Now we use the equation y equal to u plus 80, and here is u is 0 and a is 0.188, and that's t as it is. V will be 1.2. Now we can write it as t will be equal to 1.2 divided by 0.188. The time will be equal to 0.188 divided by, 1.2 divided by 0.188. The answer is 6.38 seconds. Question 6. Three particles A, B, and C of mass 0.3 kg, 0.4 kg, and 1 kg respectively lie at rest in a straight line on smooth horizontal plane. Distance between B and C is 2.1. A is projected directly towards B with speed of 2 meters per second. Now, after A collides, B with the speed of A is reduced to 0.6 seconds, still moving in the same direction. Show that the speed of B after collision is 1.0 meter per second. Now, here is the two particles. One is particle A, that is particle A. Second is this particle B, and this particle B, and third is particle C. The distance between B and C is 2.1 meter, and you see here the initial speed of The A and B, we see here the A is projected towards B with speed, that is UA is equal to 2 meter per second, but the particle B is at rest at initially, and A collides with B, the speed of A is reduced to 0.6 meter, and the particle A collides with B, this collision A and B. The After collision, the speed of A and speed of B become changed. You see here the speed of B, UB, PB, that will be equal to, we have to prove that speed is 1.05 seconds and the speed of A is reduced to 0.6 meter per second. Now, you see here the particle A collides with particle B, therefore we use the law of conservation of momentum. In the law of conservation of momentum, the momentum before collision equal to momentum after collision. Total momentum before collision will be equal to momentum after collision. Now you see here the momentum before collision will be equal to NAGA plus NBUB. That's equal to MAVA plus NBVB. MA is 0.3, multiply UA is, you see here is P2, plus NB is 0.4, multiply U is 0, M is 0.3, VA is 0.6, now NB is 0.4 into VB. Now you see here that is equal to 0.6 plus 0 equal to 0.3 multiply 0.6, that's equal to 0.18 plus 0.4 VB. Now that will be equal to 0.6 minus 0.18 divided by 0.4. We see the answer. Now 0.6 minus 0.18, that's equal to 0.42 divided by 0.4. This answer will be equal to 1.05 meter per second. This is the speed of the particle B, 1.05 meter per second. This is the answer. And the next question here is the after the collision between A and B, B moves directly towards C and particle B now collide with C. After this collision, the two particles coalesce and have a combined speed of 0.5 meter per second. You see here the particle B now collides with the particle C. Now this is the particle B and this is the particle B having the speed is 1.05 second. This is the speed 1.05 second. We see the initial speed and this is the particle C and the particle C is at rest at the and the particle B moves towards C and collides. After collision, both particles combine and having the speed. Now we see here this is the initial speed v dash v known as v dash 0. Now this velocity speed becomes v dash a and v dash b and v dash c. The combined speed is 0.5 meter per second. Now again we use the law of conservation of momentum. Now the total momentum before collision will be equal to m into MB into UB dash B plus MC U dash C equal to MBV dash C V dash C plus MC V dash C. Now you see here, this is the mass of the particle B. So the mass of the particle B is 0.4 into 1.05 plus mass of particle C here is, you see, mg. Now we can here define m, and that is 0, and mb is 0.4, and the velocity is reduced to 0.5 plus mc is, we have to find mc, and vc will be 0.5. Now we see here that's equal to 4.20. 0.4 multiplied 1.05, we see that multiply 0.4, the answer is 0.42. 0.42 plus 0, that's equal to 0.20 plus 10 into 0.5. That's value return 0.42 minus 0.2, that's equal to 0.22. And n will be equal to 0.22 divided by 0.5. 0.22 divided by 0.5. The answer is that is 0.44. Part C, find the time it takes from the instant when B and C collide until A collide with the combined particle. You see here when the particle A collides with the particle B, at this time, at this instant, the speed of the particle A was 0.6 meter per second, and the particle speed of particle B was 1.05 meter per second. Now, firstly, we find the time the particle B takes to collide the particle C. Now, we see that the time taken by the particle B to reach the particle C, that the time will be equal to distance over speed. Now the distance is covered, the particle B is 2.1, and the time, that is the speed at this instant when the after colliding the particle A, that the speed was 1.05 meter per second. Now therefore the time it takes to reach the point particle C is 2 seconds. And we see that the particle A covers distance in 2 seconds. Now the distance covered the particle A in 2 seconds, we know that S equal to V UA into T. Now the UA is 0.6 into 2, that value will be equal to 1.2 meter. When you see that when the particle B strike A, the particle A covers the distance 0.1.2 meter distance covered, and it covers the distance particle A covered distance 1.2 meter. You see that the 2.1 minus 1.2, the particle is 0.9 meter away. Now we suppose that the T is the time. Now T is the time the particle A reaches the combined particle B and C. Now let X be the distance covered the combined particle B and C in this time interval T. We suppose that is distance X. It covers in time when the particle A collide with combined particle. Now let X be the distance covered by the combined particle when A collides then in time t. In time t. You see here, this is the distance covered by the particle A is the distance the particle A is suppose that S A when at this position the distance covered by the particle A that will be equal to x plus 0.9. You see here x plus 0.9 and the distance covered by the particle B and C that is in this interval that is equal to the SA SBC is the distance covered is x. Now the difference between these distance SBC minus SA equal to 0.9. Therefore, we can write it as SA. It is the distance covered by A that will be equal to BA into T minus VBC into T. And T is the time when the particle A reaches the combined particle B and C. And VA is now is 0.6 into T minus VBC is 0.5 into T. That value is equal to 0.9 and that is equal to 0.1 T equal to 0.9 and that T will be equal to 9 seconds. And this is the answer when the particle A collides with B and C. Question 7. A particle P traveling in a straight line starting at rest from a point O. The acceleration of P at T is after leaving O is denoted by A meter per second square, where A is equal to 0.3 T power 1 over 2 and E equal to minus K T minus 3 over 2, where K and T are constant. Now find the velocity of P at T equal to 4. You see here the equation that T equal to 4, that equation we use to find the acceleration. Because in this equation T is greater than 4, therefore that equation we use to find the velocity. Now you know that the velocity will be equal to the integration of the acceleration. We can find the velocity of the particle. That value will be equal to A into dt plus C. Now here is the A is 0.3 into T power 1 over 2 plus C. Now the integration of this, where we see that the T power 1 over 2 plus 1 over that's equal to 3 over 2 and we divide it by 3 over 2 also. That value will be equal to 3 over 2 P into 0 equal to 0.3 P power 1 over 3 over 2 plus C. Particle started from rest. Therefore, the speed velocity of the particle will be 0 when time is 0. Now we put the value here, P is 0, B is also 0. Now we see that that value will be 0 equal to 0 plus C. Therefore, the equation 1 becomes V equal to 0.3 T power 1 over 2, 3 over 2 divided by 3 over 2 plus 0 and that is equal to 2 over 3 multiply 0.3 and that can be written as 3 T power 3 over 2 and that is equal to 3 on the 3 0.1 multiply 2 that is equal to 0.2 T power 3 over 2 and that is the velocity at we have to calculate the T equal to 4. Now that when T equal to 4 the velocity will be equal to 0.2 into 4 power 3 over 2 that's equal to 0.2 into 2 power 2 in power 3 over 2 2 will be cancelled. That value will be equal to 0.2 into 8 and that is equal to 1.6 meter per second is the velocity. Part B, it is given that there is no change in velocity of P at T equal to 4 at that and that the velocity of p at t equal to 16 is 0.3 meter per second. Therefore, show that k equal to 2.6 and find an expression in terms of t. Find for the velocity of p for time t is greater than 4 and less than t. We see that the acceleration is equal to minus k t power minus 3 over 2 minus k t power minus 3 over 2 in this interval. Therefore, we use this equation and to find the velocity, we integrate the acceleration and the acceleration when we integrate it, that is equal to v equal to a dt plus c, and we can write it as integration of minus kt power minus 3 over 2 plus c dt plus c equal to that's equal to v. Now the integrate this, we see that minus k into t power minus 3 over 2 plus 1 divided by minus 3 over 2 plus 1 and plus 3. Now this value becomes minus k into t power minus 1 over minus 3 plus 2 that is equal to minus 1 over 2. Now divided by minus 1 over 2 plus 3 that is equal to minus 2kt minus minus 2 we cancel 2k over t square root plus c equal to b. Now that's the equation to find the value of c. We see that the initial value when the time is t is 0, speed is 0, when t is 0, the velocity is 0. Now we substitute this value 0 and 2k our square root of t plus that's 0. You see here the time is 4 seconds. The velocity of the particle is 1.6 meter per second. We put the value here to find c. V is equal to 1.6 and t is equal to 4 seconds. Now that value becomes 1.6 equal to 2 over 2, that's equal to k plus c. This is the first equation. Now we see that here in this question, at time t equal to 16, the velocity is 0.3 second meter per second. Now we take t is 16 and the velocity is 0.3 meter per second. And here is the equation that is the t equal to 2k 2k our square root of t plus c. Now that's equal to v is 0.3 meter per second and that's 2k into square root of 16 plus c and that's become 2 over 4 k plus c equal to 0.3. Now we can write it as 1 over 2 and 0.5 k plus c equal to 0.3 and that's a 1.6. These two equations we simplify it. This is equation 2 and equation 1. We see here if the c is equal to 1 k minus 1.6 minus k. Now therefore that's become 0.3 equal to 0.5 k plus c is 1.6 minus k. Now you see that the 0.5 minus 1 that's equal to minus 0.5 k and that is 0.3 minus 1.6 negative 1.3 minus 0.5 k and the k will be equal to 1 3 over 0.5. Now that is equal to 2.6. This is the value of k. Hence, we prove that the k is equal to 3.6. Now you see here the value of c will be equal to 1.6 minus 2.6. The c will be equal to minus 1. And the expression becomes b equal to, that is the expression you see here. So you see here the b equal to 2a over square root of t plus c. That's the b into t, k is 2.6 and square root of t and c is minus 1. We can write it as 5.2 over square root of t minus 1. Given that t comes to instantaneous, such that t equal to capital T, find the exact value of t. Now the velocity of the particle p is equal to v equal to 5.2 over square root of t minus 1. This is the velocity equation of the particle p. Now you see here, this is the capital T is the time. Now we can write it as 5.2 equal to capital T. When the time is capital T, the velocity will be 0, and therefore we can write it as, now that equation becomes 5.2 over square root of T equal to 1. And that value will be equal to capital T, square root of T equal to 5.2. We take the square on both sides, we get T will be equal to 5.2 square, and that is equal to 27.04. This is the time at instant the particle speed is 20, and this is the answer. And the part B, find the total distance traveled between t0 to t equal to capital. Now you see here, this is the velocity equation for the interval t equal to 0 to 4 seconds, and that is v equal to 0.2 t power 3 over 2, and same as here is the second velocity equation is when time interval 4 to capital T second. Therefore, to find the distance between interval 0 to t capital T, now firstly we find the distance interval between 0 to 4. Now we integrate the v, that's a v into dt, we get the velocity, sorry, we get the distance in this interval. Now we write it as 0 to 4 seconds. Now to substitute the value here, that's equal to 0.2 into t power 3 over 2 into 0 to 4 seconds. Now the integration of 0.2 into 3 power t, we see that 0.2 into 3 power 3 over 2 plus 1 divided by 3 over 2 plus 1, and this is the integration of 3 power 3 over 2. Now that interval is 0 to 4 seconds. Now we simplify it to see here, that is the 0.2 into t power 5 over 2 over, that's equal to 5 over 2, and this is equal to 0.2 multiply 2 over 5. That's t power 5 over 2, and the interval is 0 to 4. Now next is the 0.2, 0.4 over 5, that's equal to 0.4 over 5, that will be equal to 0.08. And this is the 0.08 t power 5 over 2, 0 to 4. Next is the, we substitute the value, upper bound value in this n, now 0.0208 into 5 power 4 power 5 over 2 minus, now we put the value 0 in this expression. Now you see here that is 0.08 into 0. Now the answer is 0.08 multiply 2 power 2 will be cancelled into 5 over 2 that will be cancelled. Now you see here that value becomes 0.08 multiply 2 power 5 and that's equal to, now you see here that is 0.08 multiply 2 power 5 that's equal to 64 over 25. You can write it 2.56. Now the answer is 2.56. Now find the distance between interval 4 to capital T second. Now here is this velocity between 4 to capital T second, that is equal to 5.2 t power minus 1 over 2. Now to find the distance at 2, we integrate this velocity. Now that will be equal to v into dt. And that will be equal to integration of 5.2 into t power minus 1 over 2 into minus 1 and minus 1, that's into dt. Now interval is 4 to capital T. Now we integrate this 5.2 into t power minus 1 over 2 plus 1 divided by 5 over 2 divided by 1 over 2 plus 1 minus 1 over 2 plus 1 and minus 1, that's the integration of this, that value will be equal to 3. Now that's become 5.2 into t power 1 over 2 and divided by 1 over 2 minus 3. The interval is 0 to 4 to capital T. Now interval is 4 to capital T. Now here is the capital T, we substitute it. Now 5.2 divided by 1 over 2, that value is 10.4 and that is capital T 1 over 2 minus capital T and that's equal to minus. Now we substitute the lower bound value here, 5.2 into 4 power 4 1 over 2 minus what, that's equal to 10.4 4 power 1 over 2 minus 1 over 2 4. Now t 10.4 into t square root of t. We see here we already find square root of t is equal to 5.2. Now we put the value 5.2 here and minus capital T value is this 27.04. This is the value 27.04 is the value of t. Now we substitute this value here, minus 27.04. 27.04 minus that will be equal to 10.4 multiply 4 square root is 2 minus 4 and that value you see that the answer of this value. Now we see the answer of this value is 10.4 multiply 5.2 minus 27.04. The answer is 27.04 minus 10.4 multiply 2, that's equal to 20.8 minus 4, and that is equal to 27.04 minus 16.8. Okay, now we calculated that value will be equal to minus 16.08. The answer is 10.96. Now this is our second distance. Now the total distance will be equal to 2.56 plus 10.96. That value will be equal to plus 2.56 equal to 13.52 is the total distance, and this is the answer. You see here 27.04 minus 16.8. The answer is 10.24. Now we write the second distance is 10.24. Now the total distance will be equal to S1 plus S2, and that is S1 is 2.56 plus 10.24, and that value will become 12.80, and this is the total distance.